Okay guys, so this video is going to explain how to do the graphing thing we did for the lab that you need to know for your test on Friday. So this one here is the D versus T graph, okay, and this is the V versus T. And the way that we tell is that this one's in meters, right, in seconds, and then this one's in meters per second, so that's velocity in seconds, okay. All right, my pen is leaking, sorry. All right, so whenever we're looking for the velocity at some time, so let's say in this one we'll do the velocity at 8.6 seconds. Okay, so it doesn't matter, any time, whatever time you pick, okay? And I'll give you the time on the test. So at 8.6 seconds, we're looking for the velocity. Now remember that the slope of a D versus T graph is equal to the velocity. So since this graph is curved, the velocity is going to change. Okay, guys, sorry, I got interrupted. Okay, so overall, right, D versus T graph, the slope equals velocity. Because this is a curve, that means the velocity is changing at every second. So if we're looking for the velocity at some particular time, then we can't just do the slope of this line, right? Because the slope of this line is ever changing. So what we'll do is at that time, I'll make a little mark on the graph. And then what we want to do is we want to draw a tangent line to the curve at that point. The tangent line is just a straight line that only touches the curve at one point. So I'm going to try to do my best at estimating the slope at this point. Essentially what we're doing is just estimating what the slope is at that point, which would estimate the velocity at that time. So that's not a great drawing. I want to go a little bit lower, but I'm just going to leave it for now just for the purpose of this. Okay. So this is our tangent line at that spot, and to find the slope of the tangent line, we're just going to pick 2 points. I would highly recommend picking points that line up with graph lines because it ends up being easier for you. So I'll just pick maybe like this point, okay, and that would be 9 on the x-axis, and on the y-axis it's like 2.4-ish. Estimating's okay, all right. And then I'll just keep this point because that point looks like it's kind of on like both graph lines. So it's 8.6 on the x and 4 on the y. Now you should name one of these x1, y1, and this one can be x2, y2. And then that way the slope equation, remember, is y2 minus y1 over x2 minus x1. And so I just plug into that, and the slope will equal the velocity. So y2 is 2.4 minus 4 over x2, which is 9, minus 8.6. So that's 2.4 minus 4 is negative 1.6. And 9 minus 8.6 is 0.4. And then I'm just going to plug that into my calculator. And I get negative 4. And since it's the velocity, it'll be in meters per second. So that's the velocity, the estimate of the velocity at that point. Now, if we did the same thing, but at this point, it would turn out very different, right? So let's say it was that point, and you'll see why we have to do this. So I'll do it in black so you can see the difference. But let's say we were estimating it at this point, right? The line would look a lot different at that point. Right? A lot different than that blue line, very different slope, much steeper. So what that means is that it's going faster at this point, which makes sense. That's later in the drop, and the ball has accelerated for longer. So you see why we have to do the slope of the tangent line at that point, right? In order to get the velocity there, because that's different than the velocity here. Okay? But if you did that, right, if I asked for this time, you just do the exact same thing, but you'd pick 2 points on the black line instead and do the same exact slope equation. Okay? Now, this is the V versus T graph, the velocity versus time graph, and this is where we're going to find our acceleration. So if we want the average acceleration, because the acceleration is constant, which it always will be, what we do is we basically see that this isn't curving, right? It's not curving this way. It's not curving like under or anything. This is pretty straight. Just has these bumps in it, and the bumps actually are why we have to draw a line of best fit. But really, this is pretty much a straight line. So what we do is we draw a line that basically represents this line as best we can. So you just kind of, it's okay if yours is a little bit different than mine. It's not the end of the world. Okay, something like that. Okay, kind of estimates that line. Maybe could have gone a little bit lower, but it's pretty good. Okay, you'll ignore this part because this part is when it bounced, so we're not going to worry about that part. Okay, we just want this bulk of this line. And now that we have the line of best fit, we just pick 2 points and find the slope, and that will give us the acceleration. So you can pick any 2 points, but I like the ones that are on grid lines, again, for the reason that it makes things easier. So this is 8.8 and -6. And let's go with this one, which is 8.4 and about 2.8-ish, -2.8, something like that. Okay, just estimate is fine. All right, and then same slope equation. So slope is y2 minus y1 over x2 minus x1. I'll go with this one as x1, y1, and this is x2, y2. So this becomes a equals y2, so -6 minus -2.8 over 8.8 minus 8.4. That gives me -6 essentially plus 2.8, so that's -4.2 and over 0.4. Okay, plug that in, and you get about -10.5 meters per second squared. Now, since this data is from the lab we did, we know that it was a ball dropped. So really, the acceleration should be the acceleration of gravity, which is -9.8. This is pretty close, right? It's pretty close. So that's okay. That's just due to lab error and my estimate being a little bit off and all that. So that's okay, but you should get somewhere close sort of to that. All right, as long as you do the math correctly there. So hopefully that helps explain this graphing process. But the thing you want to make sure of is that when you're looking for velocity, you're using the d versus t graph. And when you're looking for acceleration, you're using the velocity versus t graph. All right, you mix those up and it's really going to throw off your work. Okay? All right. Oh, and let's not do this, right? So in this question I said, what's the velocity at 8.6 seconds? Yes, I know you could go down here, go to 8.6 seconds and just read the graph, right? And you'd get about 4.2 or something, right? We were not allowed to do that on the test. Okay, you have to do the tangent line and estimate it that way. Okay. All right, hopefully that helps. Come see me at Collab if you're still confused.